Hello everyone. Today we are going to go through count of matches in tournament. So basically, what's happening is that you have a certain number of team, which is actually n, and then you are supposed to reduce that number of team to one team, which is the winner. And how do you reduce? How do you perform the reduction? If the current number of team is actually even, what you are going to do is that each team is going to play with another one, so you are going to have n divided by 2 matches, and then after each play the winner is going to advance and the loser is going to remain. So after each game you are going to have n divided by 2 matches, and then you are going to have n divided by 2 moving to the next step. Now if you find yourself with an odd number of player, you can actually form n divided by 2 teams, right? That is why you are going to have n minus 1 divided by 2 matches, and then you are going to have n minus 2 divided by 2 plus this one that was removed here, moving to the next round. And then now the goal is to return the number of matches played in the tournament until the winner is decided. What does that mean? Until only one team remain. So this is an example for us to understand better. So let's say you have 7 players. What will happen is that after the first round you are going to have 3 matches, because 7 is an odd number, and then you are going to have 3 matches, and in these 3 matches we gave you 3 winners, and then those 3 winners plus the remaining player here are going to advance to the next step. So you are going to have 4 advances to the next step, and then here in that step you have 4. Now those 4 players are going to form 2 teams, so we are going to have 2 matches, and those from the 2 matches the 2 winners are going to advance. And then after that we are going to have 2 teams, those who advance, and then from this we are going to have just 1 match, and that one player is going to declare the winner. So how many total number of matches did we have during this game? We had the 3 year, we had the 2 year, we had the 1 year, which actually give us 6. So given this example, how can we solve this problem? So we can solve this problem with really a straightforward approach, where in each of the iteration we are going to compute the number of matches, and then compute the number of team advancing to the next step, and then we are going to repeat that until the number of team advancing to the next step is actually 1. And then once it is 1, we just return the sum of the matches. So how would the code of such an approach will look like? So we just look like this. We need to have, like, let's say a result equal to 0, and then you need to return your result here. And then here you just need to have like a while loop while n is different from 1. Why am I saying n is different from 1? Because if n is equal to 1, that means we have reached the end of the loop. We don't need to perform any operation. So what we should do is that we need to say the result will be taking the n divided by 2. That is actually the number of matches. You do agree with me that if the number of matches is actually odd, 7 divided by 2 is actually 3. This is actually in division. So this will actually always return you the number of matches that are going to be played. And then what is the number of people advancing to the next step is actually equal to n divided by 2 plus n modulo 2. So by doing something like this, you are sure that okay, after each operation you are actually taking the number of matches being played, and then you are having the correct number of teams advancing to the next step. So let us submit this and see what it gives. So we can see that this one is actually performing pretty well. We have a great time and great memory. No, not that great memory, but now thinking of this, like, is this actually the most optimal solution you can have for this problem? And the answer is no. Why? Because here you have a while loop, you are not iterating one after the other, you are dividing by 2 after each step. So you basically have a big of log of n for this approach. But you can take look of this. You say, let's say we have 7 players. After the first game, we are going to have 3 matches and we are going to have 4 advancing to the next step. Let's say we have 3 players. At the end of this, we are going to have 3 matches and 3 advancing to the next step. The remark you can do here is that if you have 3 matches, we are going to have 3 person out. We have 3 person advancing to the next step, but we also have 3 person out. The same here, if you have 3 matches, we have 3 person out. This kind of gives you the information that the number of matches is equal to the number of people getting out. And then if you want to have just one winner at the end, that means the number of matches you need to play will be equal to the number of people you want to remove, which is actually n-1, so that we are going to leave just 1. So given that statement, you can easily say that, okay, the solution will easily be n-1. Let us submit this and see what it gives. So you can see that, okay, and then n-1 always also give us a solution, passing all the test cases. Really strange that this one is actually performing less better than the previous one. It's really strange. But the most interesting part here is you being able to kind of implement the scenario that has been described, and secondly being able to figure out this pattern, which can help you to reduce your big of log of n solution. So this is my approach to solving this. I hope you do enjoy it. Feel free to leave me any message. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.